Okay, so I'm gonna do a few problems with you guys on exponent properties, and I hope you know how to do this. Um, I'm assuming you guys already know it, so give this one a shot, I'll give you the next one. Okay, so one of the exponent properties states that, well actually let me show you one way. So if I did 7 times 7 times 7, and maybe this is a bit long. It basically just says that we're supposed to minus the exponent. So this is actually supposed to be 7 to the 5th. And this is why, because we cancel these out. And, oh, that's 6 sevens. Okay, now that is why, 7 to the 5th. And yeah, so give you the second one. Let's do 7 to the 5th, if I can write it, times 7 to the minus 1. I'll let you guys do this. Pause this video if you want to get better. And okay, I'm going to assume you guys did that. So 7 to the 5th, which is, I'm not going to write the whole thing out, which is 7 to the 5th divided by 7, right? Because 7 inverse is just 1 over 7. So we're pretty much saying 7 to the 5th times by 7 times 1 over 7. Which is the same thing as we're saying right here. So this equals 7 to the 4th from our quotient exponent property. I'll do a very quick one on the product exponent property, which is x to the third, 7 to the why do I keep using 7? Let's mix it up. Let's do e, which is some arbitrary number I made up, and we're going to have e to the 2 times e to the 5th. Okay? So what does this equal? Right, hopefully you got this. E to the 7. Just think of e as just a random base. Now, you will see this when coming to logarithms, and which you probably have already seen if you are in Precalculus. It's basically it's called the natural logarithm base, which is just 2.71 something, if you're interested. But yeah, so this is usually displayed as 2.71, but I just thought I would get you used to seeing that. I don't know. Okay, here's a bit harder one, and hopefully I don't mess up on this, because even I find it hard to keep up with these. That's 3 times 2 to the 3 and to the 5th power. Okay, I'll let you guys do this and give it a shot. Okay, so how I think about this is that 4 is a factor of 2, so well, we can think of it like, make a bar like that. 4 is really just 2 to the 2. So this is 4 right here. Maybe I'll emphasize that with the less blue color. Times this times 2 to the third and all this to the 5th power. Okay, so what did I do? Oh, oops, I completely forgot something. This is just 4, so we have to actually put the exponent from the 4, so that's 2 to the 3. So this is just 4 to the 3, I just rewrote it as 2 to the 2. So from one of our logarithm properties, it says that on the outside of the parentheses with the power thing this is going to be 2 to the 6. Just say that. And why? Well, 2 to the 2, 2 to the 2. Okay, wait. 2 to the 2. This equals 2 to the 6. That's why that is so, if you were wondering. So this is 2 to the 6 times 2 to the third. So all of this is 2 to the 9 over 5. Now this is just 2 to the 45. Why? Because we times these two together. Or if you want to think of much easier way to think of it, which I always do when I don't remember a property. 2 to the 9 times 2 to the 9, that's 18, and so plus 2 more. I probably shouldn't actually do that and make it confusing. So we'll just write it out like this. This is 2 to the 18, 2 to the 18, 2 to the 9, this is 2 to the 27, and that's 45. So 2 to the 45. There. And hopefully you got all that. If you didn't, well, hopefully you can ask someone else, because I do not know how else to explain it. Yeah, these are just practice problems, so don't feel bad if you don't understand. Goodbye.